Now, it will be very difficult for us to make this kind of diagram. This is actually a 3D diagram represented on a plane surface. And for solving the questions which are based on the PZX triangle, if we need to make a diagram like this, it will be very, very difficult, hard, as well as time taking. Especially in the examination conditions, if you have to make this kind of diagram in every question, it will take a lot of effort as well as time. So to show all these things in a very simplified version, we can simplify this particular diagram by simply looking at it from a different angle or from a different perspective. Now, how do we look at it? Let us try to understand it now. First of all, you see, we are only interested in that part of the celestial sphere which is above the rational horizon. That means this particular part, which contains the PZX triangle also. This is the part which we are interested in. We are not interested in the bottom part of the celestial sphere that is below the rational horizon, because that in any case will not be visible to the observer. So we are not interested in this particular part. Now, how to have a perspective or angle so that this bottom part can be eliminated altogether and we are able to concentrate our attention to the top part. So for this, we visualize as if we are looking at the celestial sphere from top of the zenith. Right now, we are looking at the celestial sphere somewhere from this west point, somewhere from this angle we are looking at it. But assume for the moment that you are able to go up to the zenith. Let's say you have a rocket accessible to you. You sit in the rocket, it takes off and it goes vertically upwards. Now, if that rocket goes vertically upwards, eventually at one point of time, it is going to reach the zenith of the observer.
It's like a bird eye view.
Now, we don't stop at zenith. We take the rocket still further upwards. Now, let's assume that the rocket has reached up to here. So once we have reached up to here, now we look down below towards the celestial sphere. So we are outside the celestial sphere now, and we are on top of the zenith. And you can say we are having a bird's eye view on the celestial sphere from top of the zenith. Like you see, many of the shots are taken by drones nowadays. So the drone flies high up in the sky and it takes a bottom picture, a aerial view. So that is what we are looking at it. So right now, our eye, or we are situated at where the laser pointer is, and we are looking down at the celestial sphere. Now, how does the celestial sphere appear? We will try to put it in a diagram on the right-hand side of the screen. So in the blank portion now, you will see how does the celestial sphere look from top of the zenith. Now, first of all, the celestial sphere looking from top is going to look like a circle again. So it will appear like a circle as you see on the right hand side of the screen. Now, when you are looking from top, you see this was the north point. The circle which we have made on the right hand side is basically the rational horizon of the observer. When you are looking from the top, the circumference of the celestial sphere will be the rational horizon of the observer. Anything which is below the rational horizon will not be visible to us. It will go on the far side of the celestial sphere. We will only be able to see what is on top of the rational horizon. So when we look at the celestial sphere, the circumference of the celestial sphere which we are going to look at is the rational horizon. So the circle which we have drawn on the right side of the screen represents the rational horizon of the observer. And that is why the name given to it as rational horizon diagram, because it is made on the plane of the rational horizon of the observer. Now you see we have this north point on the rational horizon. Now, as per our sign convention, we show this north point on top of our rational horizon diagram. It matches up with our charts also. We have the north direction represented upwards. So here also in the rational horizon diagram, we represent the north direction up. Now, exactly opposite to this north direction on the other side, you will have the south point. And if you go 90 degrees towards the right side of north, you will have the east point. And if you go 90 degrees towards left side of the north point, you will have the west point. So let us mark off these points in our rational horizon diagram. We have the north point here. If you go to the right side by 90 degrees, you will reach to the east point. So you see represented by E in our diagram. And if you go opposite to the north point, exactly opposite to where the north point is, exactly opposite to it, you will have the south point represented by S in our rational horizon diagram. And if you go 90 degrees to the left of north, you will have the west point represented by W here. So all these 4 points, N, E, S, W, represented on the plane of the rational horizon. Now you see, going from north up to the north celestial pole, from the north celestial pole going up to the zenith, up to Q point and up to S point. This is going to look like a straight line joining the N and S points. So if you have a look at this from top, it is going to look as a straight line joining the N and S points. So let's see it here. It is going to appear as a straight line joining the N and S points. Similarly, if you draw a vertical circle which will pass from the zenith and pass from the west point, this vertical circle passing from the zenith and the west point, and also a vertical circle passing from the zenith and the east point. So going from east up to the zenith and coming back to the west point will also look like a straight line when you look at it from top. So you see this is the W to E vertical circle line which we visualized in the celestial sphere, and exactly in the center you will have this Z point. When you look from top, the circumference will be the rational horizon, and this Z point, that is the zenith of the observer, will be exactly in the center. So let us show this Z point exactly in the center here. You have the Z point here at the center. Now from Z, if you move towards the south point, from Z moving toward the south point, once you cover an arc equal to the latitude, you reach up to point Q. So let's mark off this Q point in our rational horizon diagram. So from the zenith, when you move towards the S point and you move a distance equal to the latitude, you reach up to the Q point here. So from the zenith towards the south point, we moved an arc or distance equal to the latitude, we reached at Q point. So this Q point represents the Q point here in this diagram. Now, if you look carefully, from the Q point, if you join up the W point, W to Q, and moving further Q to E, this particular arc, E point to Q point to W point, represents the equinoctial. So we can also show the equinoctial in our rational horizon diagram now. You have the W point here, you have the Q point here, and you have the E point here. So joining W to Q to E will give us the equinoctial. So let us do that. So you see W joined with Q joined with E gives us the equinoctial. So this WQE represents the equinoctial in our rational horizon diagram. This WQE you can see here in the celestial sphere diagram. This is point W going up to point Q, going up to point E. Only this part of the rational horizon will be visible to you. If you go beyond W on this side, or you go beyond E on this side, this is going to fall in the far side of the celestial sphere, which will not be visible to us. So this will not be visible to us. So that's why you only see half of the equinoctial, which is visible to you as WQE in our rational horizon diagram. Now let's proceed ahead. Let's come back to the Z point. From the Z point, if you go towards N point, towards the north point is here. So from Z, if you move towards the north point, equal to a distance which is your colat or 90 minus latitude, you will reach at the north celestial pole. So let us show this in our diagram now. We start off from the Z point, we move towards the north point, and we move a distance equal to 90 minus latitude or our colat. The point where we arrive is the north celestial pole. It is represented by P. So let's mark this as P here. You can see the north celestial pole shown in our rational horizon diagram. Let's mark off the arc P to Z also. So this is marked in yellow, exactly same as was marked in the celestial sphere diagram. So you see P to Z was marked as yellow, and it has been marked as yellow in the rational horizon diagram as well. This is equal to 90 minus latitude or equal to the colat. Now let's take our attention to celestial sphere diagram. From the Z point, if you draw a vertical circle passing through the body is here, that is star X. So from the zenith, if you draw a vertical circle passing from the body, going up to the rational horizon to point H and going up to the nadir, this is the vertical circle passing from the body. Now, if you look from top, this vertical circle is also going to look like a straight line. And how will this look? From the zenith, you see this particular dotted line. This is how this vertical circle is going to appear. The point where this vertical circle touches the rational horizon, you see the vertical circle from Z going up to X touches the rational horizon at point H. This point H is going to be this particular point here. from the zenith going up to the rational horizon. This is the H point. Again, somewhere in between the Z and H points, you will have the celestial body, that is the star, which is represented as X here. So let's mark the celestial body also now in our rational horizon diagram. So somewhere between Z and H, we will have the celestial body shown here in the rational horizon diagram, represented by X. You can see the celestial body here. Now you can see H to X is the true altitude of the body. So concentrate on the celestial sphere diagram. You see X to H highlighted in the maroon color. You have the true altitude of the body. The same true altitude is represented H to X in the rational horizon diagram. So let's mark it with maroon color, highlight it with maroon color here also in the rational horizon diagram. Now going back to the celestial sphere diagram, you see Z to X. This is the true zenith distance of the body, which is 90 minus true altitude. So let's show it here. Z to X. Let's highlight it also with the green color. You see Z to X is the true zenith distance of the body, and it is equal to 90 minus true altitude. Another important thing in the rational horizon diagram, you see the zenith is at the center of the rational horizon plane diagram, and the circumference which you see of this particular diagram is the rational horizon of the observer. Now we know every point on the rational horizon is 90 degree away from the zenith. So this indirectly tells us that the radius of this particular diagram is 90 degrees. That means from Z, if you go to the rational horizon in any direction, it will be a 90-degree arc. So from Z, if you move towards H, Z to H is total 90 degrees. H to X was the true altitude of the body. That tells us Z to X, that is the green highlighted arc, will be equal to 90 minus true altitude.
Beta, we have almost done about 1 hour. So do you want to stop here and give it a break? Or you want to continue?
Sir, break le lete hain.
Okay, all right. Okay. Right, beta. You can take a break now. What time you should be back?
$10.
Okay, okay, all right. It's about 55. 4:10 or 4:05?
10, sir.
Okay, all right, beta. See you back. Okay, beta, sorry for the delay, little bit delay. Anyway, shall we continue now? Shall we continue further?
Yes, sir.
Okay, all right. So beta, last what we see was the side ZH. So this ZH, which was a vertical circle in the celestial sphere diagram, represented as a straight line in the rational horizon diagram. The ZX part equal to the true zenith distance, which is 90 minus true altitude, and the HX part is the true altitude of the body. So let's proceed ahead from here and finish off the missing parts of the PZX triangle.
Can compare it with the celestial sphere diagram also. Z to H, zenith to horizon, was 90 degrees. H to X was the true altitude of the body, and Z to X is equal to the true zenith distance, which is 90 minus true altitude. So we have two sides of the PZX triangle now plotted in our diagram. Let's move on to the third side now, that is P to X. So this third side, which is P to X, going further to the south celestial pole, is the celestial meridian passing through our star. So we have to basically draw the celestial meridian of the star. So pole to X. So let's come back to the rational horizon diagram. This is the pole, and this is the celestial body, the star X. And we have to draw the celestial meridian now. So let's draw it. This celestial meridian is going to appear like this. This is how the celestial meridian is going to appear. So you see, passing from the pole, going further up to point X, and eventually going up to the rational horizon. This represents the celestial meridian of the body. Now the celestial meridian of the body cuts the WQE line. WQE line is the equinoctial at point D. Now you can look at it in the celestial sphere also. Celestial meridian from the pole going up to the body X goes up to the equinoctial at this particular point. So this point here is the D point referred to in our rational horizon diagram. This is the D point in the celestial sphere diagram, and it is referring to this D point on the rational horizon diagram. Going further from D, at this point, it crosses the rational horizon. And if you see here, going further from D, it reaches this particular point, it will cross the rational horizon and go on the far side. So we have the celestial meridian of the body drawn now. Now let's mark off on this celestial meridian. From the equinoctial up to the body D to X, this basically represents the declination of the body. How much north or how much south of the equinoctial a particular body is what is its declination. So the arc of the celestial meridian contained between the equinoctial and the center of the body is the declination of the body. So dx is the declination. You can correlate it in the celestial sphere diagram also. D point on the equinoctial, X point the celestial body, D to X is the declination. Now coming back to D point in the rational horizon diagram, we know from the equinoctial, that is D point, to the pole, that is P point, is always 90 degrees. Every point on equinoctial is 90 degrees away from the pole. So D to P or P to D is 90 degrees. D to X is the declination that tells us that P to X will be 90 minus declination. The arc which is highlighted in maroon color now, it will be 90 minus declination, and it is the polar distance of the body. You can correlate it to the celestial sphere diagram also. You see, D to X was the declination, X to P is the polar distance, which is 90 minus declination. So you can see now all the three sides of the PZX triangle shown in the rational horizon plane. So as you can appreciate looking at both these diagrams, that diagram made on the plane of the rational horizon is much simpler and easier to make. And you will be able to make it in much lesser time as compared to the celestial sphere diagram on the left hand side. So this is the reason why we use the rational horizon diagram so diversely, so randomly to solve the celestial navigation based problems.
So beta, have a good look at the diagram now and let me know any doubts in any parts of the diagram.
No problem.
All clear, beta?
Yes, sir.
Okay, very good. That's excellent. Okay, so let's wrap it up then.
Now, beta, going little more deeply into the PZX triangle, we have seen all the three sides of this triangle. One side, the PZ, the yellow color side, is the colat, which is 90 minus latitude. The green color side, ZX, is the true zenith distance, which is 90 minus true altitude. And the maroon color side, which is PX, is the polar distance equal to 90 minus declination. Now, we are also able to identify and find out two of the angles of this particular triangle. Now, the first angle here, which we see or which we are able to easily correlate and find out, is angle P in this PZX triangle. Now, if you look carefully, the line PZQS represents the meridian of the observer, the celestial meridian of the observer. So pole to zenith to Q point to S point represents the celestial meridian of the observer. And if you see the side P to X to D, this particular side is the celestial meridian of the heavenly body of the stars. So this particular angle which you see here, that is angle P, is the angle between the celestial meridian of the observer and the celestial meridian of the body. And this angle is being measured in this particular direction. So you are measuring this angle in this particular direction, which is this direction. This direction, you can have a look here. This represents the westerly direction. The right side in this diagram, this part you see here represents the easterly direction, and this side represents the westerly direction. So angle P is the angle at the celestial pole contained between celestial meridian of the observer and the celestial meridian of the body mired westwards. This is the definition of LHA, local hour angle of the body. Angle at the pole contained between celestial meridian of the observer and the celestial meridian of the body mired westwards. So this angle is the LHA. So we have identified angle P of the PZX triangle. Let's move on to another angle now. Let's concentrate our attention on angle Z. Now, if you look at angle Z, this is the angle between the celestial meridian of the observer. You see PZQS is the celestial meridian of the observer, and the vertical circle passing from the body. Now this angle is the azimuth of the body. So let me represent it in blue color. You can see this particular angle here. This is the definition of azimuth. So the angle between the celestial meridian of the observer and the vertical circle passing through the body is the azimuth of the body. You can visualize here, beta, the angle. This angle basically gives us the direction in which the body is. The side PZ or NPZ represents true north, and the side ZX represents the direction in which the celestial body is. So you see, this particular angle tells us what is the direction of the body with respect to true north. And if you look a little more carefully, you will understand that this is the quadrantal azimuth of the body, or the azimuth of the body in the quadrantal notation. In this particular case, the body is northwest of the observer. You see, this is the end point represents the north direction. The W point represents the westerly direction. So this body is somewhere in a direction northwest of in the northwest quadrant of the observer. So the azimuth which this angle Z gives us is the quadrantal azimuth of the body. North so many degrees west is the azimuth of this particular body. So we have identified angle Z in this triangle. So these are the two angles which we can find out in this PZX triangle. So two angles have been identified and all the three sides have been identified. Now the only unknown item which we are not interested in, that is angle X. This is the angle at the celestial body. We do not use this angle in our calculations, nor can we find it from this diagram. We don't require it. If we need, we can find it, but we don't require this angle anywhere. So this angle is usually left unknown, and neither it is used nor it is found out. This angle is not required in the calculations. So we have the PZX triangle understood. We have understood all the three sides of the PZX triangle. We have seen the two angles of this particular triangle. Now we have understood the PZX triangle well. We have seen the three sides. We have seen the two angles. If you look more carefully on this PZX triangle, you will see that this triangle is a spherical triangle, This fulfills the condition for a spherical triangle. It is made on the surface of a sphere, that is the celestial sphere, and all three sides of this triangle are arcs or parts of great circles. You see, the PZ side is part of the celestial meridian of the observer. The PX side is part of the celestial meridian passing from the body. All the celestial meridians are parts of great circles. All celestial meridians are semi-great circles. Now the third side, which is the ZX side, is the part of the vertical circle passing from the body. All vertical circles are also semi-great circles. So this triangle, the PZX triangle, is a spherical triangle because it is made on the surface of a sphere, which is the celestial sphere, and all three sides of which are arcs of great circles. Now, how do we use this triangle in celestial navigation questions? Now, in any celestial navigation question where this triangle, PZX triangle, is to be used, you will be provided with some information. So we draw the rational horizon diagram, and whatever information is provided to us, that is fed into the diagram. We note it down, we label the diagram accordingly. Whatever information is provided to us is put in the diagram. And as you put this information, you will see that out of these 5 parts which we have discussed here, out of the 5 parts which we have discussed here, that is the 3 sides and the 2 angles, you will be given some parts of the triangle, and using those parts, you will be able to find out the other parts of the diagram or the triangle. So how will you be finding them? Using the same spherical trigonometry formula which we have used for other calculations, that is the cosine formula and the Napier's rules. Since this is a spherical triangle, cosine formula and Napier rule are applicable here, and whatever information is provided to us, it will either allow us to use it in cosine formula or in the Napier rule, and we will be able to find out everything else. The remaining part, whatever are missing, can be calculated using cosine formula and the Napier's rule. So this is the concept which we used in rational horizon based questions. So PZX triangle is a spherical triangle made on the surface of a sphere. All 3 sides are parts of great circles. We are able to identify 5 parts of this triangle, that is the 3 sides and the 2 angles. Out of these, some of them will be given to us in the question. By using the given parts, we apply the cosine formula or the Napier rules, and we find out the missing parts. As you find the missing parts, the question gets solved. So this is the basic concept which we use in solving celestial navigation question. So in the questions, now you will be using the rational horizon diagram, which is given on the right side of the screen. The diagram which is given on the left side of the screen, which is also called as the celestial sphere diagram, is not used as it is much complicated. So we will not be making the celestial sphere diagram now. I made both of them to make you understand their correlation with each other, so that you are able to understand the basic concept behind it. Now, once understood, we don't need to draw the celestial sphere diagram. We will be using the simplified version, that is the rational horizon diagram, and solving our questions. So a very, very important concept of rational horizon. The explanation is completed now.
Beta, any doubt, any query in your mind? Okay, great. So I hope it was not too much heavy, beta. Were you able to grasp everything?
Yes, sir. We'll revise once it will be done.
Okay, all right, good. So now we are all set to enter into celestial navigation. We have done the bases. We have done the horizon system, equinoctial system, PZX triangle, rational horizon diagram. So now I would request you, beta, I told you to familiarize yourself with the almanac information. I hope you are comfortable with the almanac now. So one more thing which I would like to do now is please go through the basic calculations which you had done during second mates. Calculation like calculating the true altitude, sextant altitude, we apply the corrections. So finding the true altitude from the sextant altitude and calculation of azimuth and amplitude. We use the ABC method to calculate the azimuth and we use the amplitude formula. So just revise those calculation once. And I will also be covering them, touching up on them in the next lecture. So we will continue with our celestial navigation covering up. Next topic which I am going to pick up is one which is based on this rational horizon diagram so that you get an idea of how this is used. That is the topic of star identification. It comes in question number 7 of our paper. So we will cover that topic first, and after that we will go into the site solving methods. So almanac, amplitude, azimuth, altitude correction, and so on. This will be the sequence of topics going further. So that's all from my side, beta. Anything you want to share or ask?
सर वो चार्ट वर्क का क्वेश्चन डाला था.
Okay, okay, all right. So it's on the group, beta, right?
Yes, sir.
Other people have seen this, beta? If not, you can have a look. Okay, other people have seen it. So let me open up the chart then. I'll show you on the chart. So this is the question, beta. You have one bearing of the lighthouse, P Marapas lighthouse at 1048. The bearing is given as 240. Then you have another bearing of 170 given at 1112. And then you have a fix given at some other time. What is the third time, beta? 1200 hours?
Correct, sir.
Okay, so let's write it here. There is a fix given at 1200 hours. So I have just put the information available here. They want us to find out the core steered and the no, core steered is given. They want us to find out the set and rate of the current, right, beta?
Yes, sir.
Right. अब मुझे इसमें डाउट बताओ बेटा, what is the doubt?
सर ये डाउट सर इनिशियल फिक्स रनिंग फिक्स से निकालेंगे क्या सर?
That's नहीं बेटा, हमारे पास करंट नहीं है ना, तो we cannot apply running fix.
तो फिर सर इनिशियल फिक्स कैसे निकालेंगे सर?
ओके, देखो बेटा ध्यान से देखो. फाइनल फिक्स आपके पास है 1200 फिक्स.
हाँ सर.
Right. So if I join this 1200 fix with this lighthouse P मेरा पास, मैंने अभी इसको ज्वाइन कर दिया है.
तो फिर बाद में 3 पॉइंट बेयरिंग से करेंगे.
Right, it becomes a question of 3 point bearing, correct बेटा?
ओके सर. सर एक और डाउट है, ये जो अपना कोर्स टू स्टेयर है जो दिया हुआ है क्वेश्चन में, उसमें एक साथ में 10 डिग्री का लीवे भी दिया हुआ है, तो उसको अप्लाई करके नहीं निकालना ना, ये वाला अपना पोजीशन 1200 का, वो डायरेक्ट निकलेगा ना, करेक्ट सर?
सर
बेटा 1200 की जो पोजीशन है ये तो दे रखी है, बियरिंग एंड रेंज.
हाँ जी सर।
So whether it is leeway, course to steer, current, nothing matters. 1200 fix is given to us.
सर ये क्वेश्चन है कि सर जो बीम पे मारना है वो इफेक्टिव कोर्स पे बीम मारना है या नॉर्मल सीटीएस पे जो 290
ओके। बेटा जब भी कभी बीम बियरिंग ली जाती है तो वो CTS पे ली जाती है हमेशा, कोर्स स्टीयर्ड पे या कोर्स टू स्टीयर पे, never on the effective course. The vessel's fore and aft line will be in the direction of the course steered.
ओके सर, अंडरस्टूड सर।
ओके बेटा,
हो जाएगी सर।
ओके ऑल राइट, अब हो जाएगा।
हो
हो जाएगा सर अब तो।
ओके बेटा,
सर
ग्रेट।
मतलब वो जो 1200 की पोजीशन है वो 207 की बियरिंग है 9 माइल्स राइट?
या बेटा 90 डिग्री माइनस योर कोर्स स्टीयर्ड।
ओके सर, थैंक यू।
Okay, you are steering a course like this. So whatever course you are steering, 90 subtract 90 from it and you will get the bearing of the lighthouse.
सर इसका कोई और मेथड है या सिर्फ ये ऐसे ही है 3 पॉइंट से ही निकलेगा ये?
यही मेथड है बेटा,
यही
3
है ना
पॉइंट
सर?
bearing से आप CMG निकालोगे, apply that CMG to the final fix, you get your initial fixes also.
बाद में तो हो जाएगा सर पक्की तो।
Right. Okay. So good beta, today was a little heavy session, but if you have understood it, then you have understood a very difficult concept of celestial navigation. Okay, so let's call it a day. Have a good break. So I'll see you in the next class.
एक रिक्वेस्ट थी सर। सर 7th 8th नवंबर और 9th को ना सर मेरी शादी है, तो उस टाइम पे अगर पेपर ना हो तो अच्छा होगा मेरे लिए। 7th 8th को सैटरडे संडे है।
तो पहले रख दो, पहले रख दो।
सचिन भाई जी सारे बंदों को शादी में बुला लो तो शायद तो कुछ हो जाए।
Congratulations। वही बैठ के एग्जाम दे देंगे सर सारे।
एग्जाम सबको इनवाइट कर लो, एग्जाम कैंसिल।
सब आ जाए यार, कोई प्रॉब्लम नहीं है।
ये आइडिया है था।
अरे वैसे हमको छोड़ सर को इनवाइट कर ले तो सब सही हो जाएगा।
आ जाओ सर, पालमपुर घूमने आ जाओ।
Congratulations beta, first of all congratulations, you are starting a new innings, all the best to you. So बाकी रही एग्जाम की बात, तो ऐसा है बेटा, we will have the schedule as we can fix it up, but you don't worry, even if you leave some paper, no, 7th is a holiday ना, 7th is Diwali ना बेटा।
So 7th को हॉलिडे है,
सैटरडे है, 7th को हॉलिडे, 8th को भी हॉलिडे है, संडे है।
तो 9th is a Monday, हाँ?
यस सर, अगर 9th
सर ये सैटरडे वाली क्लास भी सर दशहरे वाले दिन ले लो सर।
ओके बेटा, एक मिनट। 7th is दिवाली, दिवाली is falling on a Sunday, हाँ?
सर 4th को दिवाली है सर, 4th नवंबर को दिवाली है।
4 नवंबर में।
ओके,
4 तारीख को दिवाली है सर।
ओके, 4th को दिवाली है और तुम्हारी जो है बेटा फंक्शन इज ऑन 7th 8th एंड 9th। देखो बेटा 7th को तो वैसे भी एग्जाम नहीं होगा, इट्स ए संडे। 8th एंड 9th को बेटा एग्जाम हो सकते हैं, बट यू डोंट वरी, यू गो अहेड विद योर प्रोग्राम। अगर तुम्हारा कोई एग्जाम यहाँ पे मिस भी हो गया, और नाउ ऑब्वियसली इफ यू आर गेटिंग मैरिड ऑन 8th एंड 9th, you are here only ना आफ्टर 14th also?
Yes sir, here only sir.
So we can fix up your exam later also in any of the dates, not an issue. So हमारे पास एक तो 12th का डे रिजर्व में रहेगा, we'll try to fix it up on 12th or 13th.
Yes sir, no problem sir.
So अमित बेटा कमेंट्री सबको सुन रही है, माइक ऑफ, वेरी गुड। So you can go ahead with your plans beta, not an issue. We will try to see if there is a exam in those days, not an issue, we will schedule it somewhere later, not an issue.
Okay sir, thank you sir.
और सर ये सैटरडे को भी सर क्लास अगर नहीं है वो तो सही है।
बेटा अगर हम क्लास नहीं रखेंगे ना, लेट मी सी, तो हमारे आवर्स पूरे नहीं होंगे बेटा, किसी और सैटरडे को रखनी पड़ेगी।
सर दशहरे वाले दिन ले लो सर।
हमने कौन सा दशहरा मनाना होता है?
फ्राइडे को कर सकते हैं ना सर,
शाम
फ्राइडे
को
को
ही
करा
बनाना था
लीजिए।
दशहरा।
फ्राइडे को ही रख लो सर दशहरे वाले दिन।
Friday cannot keep beta. Friday is official holiday. Let me see. Friday को तो yeah, difficult beta. Friday is difficult. Friday cannot.
लॉग बुक एंट्री सैटरडे की कर लेंगे
Say again बेटा.
सर। लॉग बुक एंट्री सैटरडे की कर लेंगे, फ्राइडे को क्लास करके।
यहाँ नहीं हो सकती बेटा, ये इलेक्ट्रॉनिक लॉगबुक है। Okay.
ठीक है सर।
Okay, so let it continue that way. You can request the faculty members to be little light on that day. मेरा लेक्चर नहीं है कोई तो, otherwise I could have at least managed my lectures, but I don't have a lecture with you on Saturday. So try to keep it.
लैपटॉप ऑन करके छोड़ देंगे सर।
सर कोई बात नहीं सर, ठीक है सर, देख लेंगे सर, कोई नहीं।
Right. Okay beta, see you then. We call it off. Bye bye.
थैंक यू सर, बाय बाय।
Thank you beta.
Thank you. Bye bye sir.
थैंक यू सर।